Welcome to qnawire.
This we're going to explain how the splitting works for the isopropyl group in the following molecule. We have an halogen X CH that is connected to two CH3 groups. In order to represent this in a simple way, we're going to write down an hydrogen over here, and we're going to get CH H H and CH H H. So the first thing that we need to do is identify the hydrogen atoms that are of the same type. In this case, let's label the hydrogen atoms over here as A because all of them are going to be chemically equivalent. Why is that? Because here we have the same type of chemical environment on the carbon atoms that are attached to the hydrogens. And finally, the other type of hydrogen that we're going to have is B. So what we're going to find in the spectrum is one of the signals corresponds to this hydrogen B, which means that it's going to integrate to only one hydrogen atom. Integrates to one hydrogen atom. How do we find that integration? Whenever we do the NMR spectrum, we're going to find different peaks, and the area underneath the peaks is normalized in such a way that it allows us to say how many hydrogen atoms come from that signal. Next up, the other signal that we're going to see is corresponding to all of these hydrogen atoms. And since all of them are chemically equivalent because the chemical environment, meaning the bonds that are connected to each other, are the same, they are going to appear on the same signal. So HA integrates to 6 hydrogen atoms. Now, to know the splitting pattern, what we can see is that a general rule when we have simple spectrums, whenever we're not dealing with couplings that are different among each other, is that we're going to have n plus 1 signals, where n is equal to the number of neighbors that we have on each hydrogen atom, and this number of neighbors needs to be of different type. For example, the neighbors of hydrogen A would be only hydrogen B. The other hydrogens A that have the same chemical environment do not count for this splitting of signals. Okay? So, in the case for hydrogen A, the signal amounts to 6 hydrogen atoms. We have only one type of neighbor, which is hydrogen B. So, the signal would have two different signals, which corresponds to a doublet. In the case of hydrogen B, it integrates to one hydrogen atom, but it has 6 neighbors. So that means that we're going to have n plus 1 signals, which is 7 signals, which is accepted. So here's where the 1 to 6 ratio comes into account. Hydrogen B integrates to only one hydrogen, and hydrogen A integrates to 6 hydrogen atoms. And that would be all. Thank you very much, and have a good one.